Let's find the variance and the standard deviation of the heights of 12 of our fellow students. So remember, the variance and standard deviation, their calculation is almost identical. They just vary at the end whether or not I take a square root. Right? The variance and standard deviation give you the same thing, plus or minus a square root. So let's remind ourselves of what the variance equation is. The variance of a set X is the sum of the square distances. So that right there is telling me, so my order of operations is take each X value, subtract from it the average, right? That gives me this parentheses. So find the distance between each value and the center, and then you square that distance, you square that difference. And then after you have squared differences for every one of your values, the sum tells you to add those up, right? So that's the order of operations. Perform the subtraction first, square that difference, then add them all up. Because we are finding the variance of a sample, we'll divide by the degrees of freedom n minus 1. And that's how we're going to go about this. So let's actually write the sum. So that sum right there, that sigma, tells me to add a lot of things. So don't have the sum if you actually have the addition of a bunch of things, right? The sum tells you to add. So let's actually write out what the sum would give us. The first X value is my first height, 69.65. So that's where that X is right there. 69.65 minus the average of these heights. Well, I don't know that yet, so we have to figure that out. Let's go back up to our set. And reminder, the average of a set X is the sum of all of the values divided by n. So if you add 69.65 to 66.25, and you add all of these until you get to the end, 50.64 and 53.35, and dividing by n, so we have 12 heights of students, so we'll divide by 12. The sum of all of this gives me 723.95. Divided by 12 gives us an average of 60.33 centimeters. All right, so that's my average, 60.33. So I take that difference and I square it. I will then add to that, I'll do this for every value. So the next value, the next height was 66.25, right there. I'll subtract from it the average, 60.33. And after I perform that subtraction, I square. Let's write out one more. The next value is 55.3. So X minus mu squared. Right, this sum right there tells you to add all of those. So we keep going until we write out, let's write out the last two. So the second to last data point is 50.64. So 50.64 minus the average squared. And the last data point, 53.35 minus the average squared. And then look at your equation there. After you add up all those squared values, you need to divide by n minus 1. In fact, let's go ahead and tell ourselves what n minus 1 is. 12 data points minus 1, we divide by 11. Okay, so the order of operations says perform the subtraction first. So I'm going to borrow some space from the standard deviation. Let me see if I can squeeze it in. So this difference here, 69.65 minus 60.33 gives me a difference of 9.32. And that difference is being squared. I add to that 66.25 minus 60.33 squared. That gives me 5.92 squared. Right, it's just simplification at this point. Let's see, the last one, 53.5 minus 60.33 squared is minus 6.98 squared. Okay, next step in the order of operations is to actually tell ourselves what these squared values are. So 9.32 squared gives me 86.86. The 5.92 squared gives me 35.05. And we do this for all of them until we get to the last one, minus 6.98 squared is 48.72. All right, next step in the order of operations is perform that addition. So the sum of all these squared differences is 409.05. And when we divide by the degrees of freedom, 11, we get a variance of 37.19. So notice this was given to us as the sum of the squared differences divided by a natural number. So this is in centimeters squared. Now, if I want to turn that variance into a standard deviation, the standard deviation is the square root of the variance. So I just need to square root 37.19 centimeters squared. That's going to give me 6.10. Now just centimeters. So the standard deviation of the heights of the 12 students in our statistics class is 6.1 centimeters.